I'm Jeff Griffith with Becker Aviation.
I'm Bill Moody with Eaton Carter.
And we're here today to go over the disassembly, inspection, and reassembly of the Eaton Carter hydrant valve model 60554. Now what we have in front of us today is the 60554 and also model number 61654. Just for demonstration purposes, we wanted to illustrate the two valves are the same internally, but they have two different mounting flanges. The 60554 is for a 4-inch flange, and the 61654 is for a 6-inch flange. We're going to be working with the 60554 today, but again, all internal parts are going to be the same regardless of the two models. With the 60554 or the 61654, there are many pilot valve options, both single pilots and dual pilots. Today, we have two different models. We have the option V, or 47900, or option X, which is the remote pilot, 64230. In later videos, we are going to demonstrate these pilot valves in greater detail.
So some of the many benefits of our newer style pilots is the newer style pilots really work off of more of a mechanical interface compared to the older pilots. We removed a lot of the smaller orifices, which could get contaminants caught into the pilots. And it's also just an easier operation for the pilots.
Before we get started with the disassembly of the 60554, we just want to highlight a few of the key points if there's any questions if your hydrant valve is in compliance with EI 1584. The first thing that you want to look at is your main large poppet. If you have a dull looking poppet, that's most likely going to be the old style aluminum. And you would have to change that poppet to make it in compliance with EI 1584 4th edition. Another thing that you want to look for is on your aluminum two-piece upper half, the recessed bolt holes. If you have the two-piece aluminum upper half and the bolt holes are flush on this flange, you want to go ahead and update and change out the upper half to the recessed bolt holes. The last option that you may run into is if you have the original ductile iron upper half, which would be red in color. That upper half is in compliance with EI 1584, and you would just have to inspect the poppet to ensure that it is updated to the new stainless steel poppet.
Another tool you can use is we do have several service bulletins on the Eaton Carter website that goes in a lot more detail about exactly how to inspect some pictures of what you're looking for in the poppet. You can also go by the serial number of the hydrant valves, if you can still see the serial numbers.
At this time, we're going to go into the disassembly of the hydrant valve, and we're going to separate the upper from the lower. This is going to be done utilizing an Allen head socket and a ratchet.
It's also kind of good to highlight while Jeff is taking the upper half off. Our upper halves are actually field replaceable. What that means is you don't really necessarily need to take the complete hydrant valve off of the hydrant pipe and take it back to the shop. As long as we know we have good isolation or we've shut off hydrant pressure to the valve, we can just simply remove the upper half, repair it, and put it back on.
Once we have all the bolts removed, we can now remove the upper from the lower. And we're going to set the lower off to the side as we focus on the upper for the time being. One thing I wanted to point out on the bolts is you will have one that is shorter than the others. And that short one is going to be placed right above the service valve. And we'll go into greater detail when we go for reassembly. Now, to disassemble the upper half, we have a retaining ring. And we're going to take a small screwdriver and get behind that retaining ring. Just pull it up just a little bit so we have access to remove the poppet retainer. And to do this, we're just going to rotate and walk that ring out of its groove.
Now there will be a spring inside this poppet guide as well, so you want to make sure you're putting firm pressure down on the poppet guide.
And once the ring is off, you can remove the poppet guide, the retaining ring, and we're going to put the items in reverse order as they're assembled inside the upper half. Now we have the poppet guide spring. We're going to remove that. We're going to have the cup that fits down in that spring. We're going to have our center pressure equalization spring and our pressure equalization poppet. And the last item is going to be our gasket between the pressure equalization poppet and the main poppet itself. And we're going to talk about more on the placement of this gasket when we go for reassembly. At this time, we can pull out our main poppet assembly, set that off to the side, and we have now removed all components from the upper half. If you'll notice, all the Allen head screws that are inside the housing, this API ring is replaceable, and when you do have to replace it, you'll get all new screws, an O-ring, and a replacement API ring with a bottle of green Loctite. And we want to make sure when we replace these screws that we have a minimum of 8-hour cure time before we go to put this upper half back into service.
And the cure time, again, is just really to make sure that Loctite has set on the threads. If you introduce fuel too quickly into that Loctite, it actually washes it away from the threads, and you kind of hamper the effectiveness of the Loctite.
Now, to disassemble the main poppet from the shroud, we have a snap ring. And there'll be a little tab that we can take a little screwdriver and just get on the side of that and remove that tab from the groove. And now we can just walk this retaining ring off. And now we can remove our shroud. Now we can remove our quad seal from our main poppet. And inside the quad seal is going to be a retaining ring. And you could just separate the two components like that. Now at this point, we have everything disassembled on the upper half, and now we're going to go into some inspection items before we reassemble. Bill, you want to talk about the main poppet itself?
Yes, Jeff. So with the main poppet, essentially what we're looking for is any area where the quad seal would set. So we have the groove where the quad seal is going to set on this poppet. We just want to make sure there's no scratches, gouges, or nicks. We want to make sure it's a good, smooth area. Another area to look at is inside the poppet as well. This is where the pressure equalization poppet is going to rest. We want to make sure that area is smooth. Again, no scratches, nicks, or gouges. Another thing we want to inspect is the actual equalization poppet. You'll notice we have the raised area. This is actually what comes in contact with the hydrant coupler as the hydrant coupler is connected. If this is worn down, then obviously it's not going to push down and release any pressure from the hydrant valve. So it's another good key component to make a quick check on. So Jeff, what are some of the things you will look at for the API ring?
At the conclusion, we're going to go into some more inspection of the API ring. But what we don't have a gauge for is this inside surface. And this is the surface the nose seal for the coupler is going to sit against. And potentially if we have any gouges or cuts or scrapes on this surface, it may hamper the sealing capability during an active fueling event.
Okay.
Which, if you see that, it's a good chance you may need to change that API ring.
And the API ring is critical because remember, this is what actually keeps the hydrant coupler connected to the hydrant valve. So if our API ring is showing some types of wear or not passing the test that we're going to go through, you could run the risk of the hydrant coupler actually separating during a fueling event.
So at this point, once we've completed all our inspection, we just want to make sure that we're cleaning all of our surfaces, all of our parts. We don't want to introduce any dirt or debris back into the upper half when we go for reassembly. At this point, we're going to put our shroud back on our main poppet. And I like to put the shroud on first because that allows the quad seal to be able to be held in place and it won't have the chance of backing out. Again, we got to have our retaining ring. This can go on in any direction, and we're just going to start this one edge in the groove and just walk that around, and when it's securely in place, you'll hear it snap. Just like that. Just give it a little tug, make sure everything's secure. Now we can go ahead, we can put our quad seal on. This quad seal can go in any direction. There is no upside down or right side up. Put that in the groove. Next, we're going to put in our retaining ring. It's critical that we ensure we put this retaining ring back in place every time that we disassemble. This is the ring that's going to allow the quad seal to remain in its shape in the poppet as it is. Without the retaining ring in there, there's a potential of this quad seal from rolling up on itself and getting pinched in between the poppet and the API ring.
And obviously, if you have that condition, what could happen is we're going to have hydrant pressure that could leak out of the poppet when it's not being used.
And this retaining ring has 3 wraps. We want to ensure when we're putting this in place that the wraps go one on top of another and they don't get intertwined. So as we come on the second wrap, this is where it's going to be critical that we get that second wrap started on top of the first one. So you may need to take a little screwdriver, ensure that you're not cutting that quad seal, and make sure that that second wrap is starting on top of the first one. And again, as you come up on the third wrap is going to go on top of the second. And once you have everything in place, just give it a quick glance, make sure everything is straight. Once everything's straight and in place, you can go ahead and take the main poppet assembly and drop it down into the housing. Try to get it centered as best as possible. Now we have our gasket. This gasket's critical that we put this in the right position. As you notice, there's going to be a raised edge, and on this side it's going to be flat. We want to make sure that the raised faced edge is facing up as we set this down inside the housing.
If this is installed backwards, potentially what could happen is, again, we could have fuel leaking through this pressure equalization poppet. So we definitely want to make sure that orientation is correct as you install.
Next, we're going to put the pressure equalization poppet down, face down. We're going to drop that in the housing.
And once you drop this poppet into the housing, it's not super critical to have it centered, correct? Because once we complete the install, we can actually go flip the valve and recenter it that way.
That's correct. Next, we're going to put the small equalization spring in. We're going to put the cup that the large spring sits on top of. The large spring. Next is going to be the poppet retainer. And the retainer ring. I like to wrap that around my arm first. And as I center this, we need to make sure that the poppet retainer is centered inside the poppet itself, and the legs are below the groove so I can install the retaining ring. Now as I go, just as I disassemble this, I can get the ring started, rotate the poppet retainer around till the spring snaps in place. And as we rotate around and get our retaining ring back in place, we want to make sure that the gap in between the retaining ring is in between 2 legs of the retainer. Once we ensure that, we can flip it over. And as Bill mentioned earlier, we want to give our equalization poppet just a quick push and make sure everything's aligned in place. If we're misaligned at this place, you'll hear the spring snap in place and get everything realigned. At this point, the upper half is now complete, and we're going to move on to the lower half. We're going to remove the O-ring that sits on top. This is going to be the seal between the upper and the lower. And then we're going to flip the valve over because everything is going to come out of the bottom. Now we see we have 6 brass screws here. We want to make sure that we're using an impact screwdriver.
And when we mention impact screwdriver, this is the proper tool. This is called a hammer impact. The tools we don't want to use is things like air impacts or electric impacts to remove any screws or bolts on these hydrant valves.
We want to make sure, the reason we're using this is these screws can be difficult to get out, and we don't want them to strip. Once we've gone around one time, that should loosen them up enough, and we could just use a Phillips head screwdriver to remove the screws.
Now, it's just removing the screws. It's imperative to remember to leave 2 screws in. We don't want to completely remove all the screws because there is a spring underneath this piston.
And I'm going to loosen these 2 screws up just to make sure that they're ready to come out. Once I have these started, I am going to go ahead and put my hand on top.
So the pressure behind this piston spring then is not heavy enough where you would need some type of device to keep it closed, correct?
No.
Okay.
And slowly raise it up. There's your retainer with an O-ring that sits underneath of it. Here's going to be our main piston. Our main piston spring. There's going to be a washer down in the very bottom. And the purpose of this washer is just for the spring to sit on top of. And then you're going to see a gasket down below. And you may need to take a pick and bring the gasket out. Last thing you want to remove out of this inside is going to be your Teflon seal. And there is going to be an O-ring behind it. It's going to be an O-ring energized Teflon seal. So again, a little pick or a small screwdriver. We're going to be careful just to gently get behind there, not to scrape any of the surfaces that the O-ring and the Teflon seal will ride in. And you can bring those 2 components out at one time. And there's the O-ring, there's the Teflon seal. Now at this point, we have everything removed out of the inside of the lower half, except the center shaft. We're also going to remove, inside the piston is going to be another Teflon seal and an O-ring. And this is going to be the seal around the center shaft. Again, we're going to use a pick and just gently get behind there, remove that Teflon seal. And also the O-ring. Once we get the O-ring out of its groove, there's the O-ring. And when it's all put back together inside that piston, and it looks just like that. Now we have everything out, as I mentioned. Now our center shaft. Bill, you want to talk about how the center shaft is installed at the factory?
Sure, Jeff. So the center shaft is actually not removable in our hydrant valves. We cryogenically freeze our shafts. We insert the shaft into the body, and as it warms up, it expands and fits into the cavity. So this shaft is not going to come out during operation. In the older valves, you may find that there could be a screw and a washer in that down by the shaft. That shaft is no longer used because we do cryogenically freeze the shaft in place.
So you could remove the screw in the washer if you want.
Correct.
They're not needed.
You could remove the screw in the washer. It's no longer needed.
Excellent. All right, this time we have one more seal to remove, and that's going to be our main piston quad seal. And that's going to be held in place with this retaining ring and the 6 screws here. You don't have to remove all these screws, but you can if you'd like. But one does have to be removed and the other 5 can just be loosened up. Once you have the other 5 removed, you should be able to remove the retaining ring, and then your quad seal will come out of its groove there. The last item that we have to remove is going to be the service valve. So we're going to flip the valve back over. We're going to remove the roll pin. It may be necessary from time to time to use a punch and a hammer to get this roll pin out, and it may get damaged as well. So you may need to have a spare roll pin to replace on reassembly. At this point in time, you can get a large crescent wrench, remove the service valve, and the service valve is going to have a large O-ring. That large O-ring is going to seal against the main surface on the lower half. And you can also separate the service valve seal from the nut. Simply twist the service valve and you can remove the large nut. All right, once we have the nut removed from the service valve seal itself, we can go ahead, there is a small snap ring inside there, and we can take our snap ring pliers once you get it started out of there, you can work it around and remove the snap ring from the seal, and there's the 2 components separated. At this point in time, everything in the lower half has been removed. Now that we've completed the disassembly process, we're going to go over inspection of a few items before we reassemble. Bill, do you want to point out a couple items we need to inspect prior to?
Sure, Jeff. So the first thing we're going to inspect is the main piston. With the main piston, when you remove it, it actually might be a little bit wet. The first thing we want to do is dry off the piston. The reason why we're going to do that is if the piston is wet, and if you do have small scratches, that fluid can actually fill up that scratch and you may not be able to see it very well. So we always recommend to dry off the piston and then just kind of inspect the outer surface of the piston. You don't want to see deep scratches or gouges. Another good practice is kind of run your fingernail along the piston edge and see if you feel any type of scratches as well. We also want to inspect where the quad ring sits on the piston. We want to check the groove, make sure again there's no nicks, scratches, or gouges. Another area we want to inspect is our maintenance valve. So as Jeff mentioned, this is a molded seal on the maintenance valve. The maintenance valve really serves 2 purposes for us. The first one is to isolate potentially the upper half from the lower half. We use a maintenance valve. If we want to just maintain the upper half, we can close the maintenance valve and our isolation valve, and that should prevent hydrant pressure from going to the upper half. We also use it as a troubleshooting tool. So later on in this video, we're going to talk about how to test for a hot pit and what a hot pit is. So this maintenance valve is critical in performing that diagnostics. So when I'm looking at the molded seal, what I'm checking for is any indentions, cracks, scratches in the seal. What can happen with these maintenance valves is the technician could tighten this maintenance valve too much and it will press into the orifice in the valve. That'll cause deformation in the seal, and what you'll have is a leak by through the seal, giving you a false positive or negative during your test. So the next thing we kind of want to inspect is the pit valve itself. So as we mentioned before, we want to inspect the main shaft. Again, the shaft is cryogenically frozen in place, so we don't recommend trying to remove the shaft. If you do inspect the shaft and you do find deep scratches or gouges or any kind of deformation, we recommend just replacing the complete valve. We also want to check the sliding surfaces where the piston rides inside the hydrant valve. Again, just make sure we have no rough edges, no nicks or scratches. And also checking where all the Teflon seals and O-rings sit as well. Make sure we have a nice, clean, smooth surface. The other thing one would check is where that maintenance valve actually goes into the hydrant valve itself. Inside where the maintenance valve goes into the hydrant valve, you're going to see two small holes. One hole is going to have a very small orifice in it. We just want to make sure that orifice is in place and we don't see any debris inside that orifice. This orifice is actually what controls the opening speed of this hydrant valve. The other areas we want to inspect is the piston retaining ring. Again, anywhere where we have O-rings or Teflon seals against the surface, we just want to quickly do a quick inspection of that surface. Again, checking for scratches, gouges. Jeff, is there any other areas that you would inspect?
No, Bill, I believe you've covered everything.
Okay.
All right. Once we've completed our inspection of our components, we want to make sure that everything is clean and dry. We don't want to introduce any dirt or debris into the valve on reassembly. First thing we're going to do is we're going to take our snap ring pliers and we're going to insert the seal back on the stem for the service valve. Once that we have that put in place, now we can put the nut back on the service valve. And we'll reinsert this into the housing later on in the reassembly process. Next, we're going to install the O-ring and the Teflon seal inside the piston assembly. First, we take the O-ring and we put the O-ring inside that groove first. And once we have that in there, we just want to put our finger, smooth everything out. Next is going to be our Teflon seal. As you see the Teflon seal, it has no ridge on either side, it's flat, and it can go in any direction.
Okay.
And this is going to sit directly inside that groove as well. One thing about Teflons is you want to be really careful and not put any big bends or creases inside of them. It's not like an O-ring, it will not come to its original shape and could prevent its sealing efficiency during operation.
It can also prevent reinstalling the piston. So if you do have a kink in the Teflon, you may feel a little bit of resistance when you slide it back into the shaft, and that can actually cause more damage to that Teflon seal as well.
Once you have that Teflon seal installed, again, you just want to rub your finger around there, make sure everything's smooth back out and that Teflon is securely inside the groove. At this point, we're going to install our quad seal on top of our piston. This quad seal can go on any direction. Once we have that installed, we're going to reinstall our retaining ring. Again, we're going to use our Phillips head screwdriver to secure all the screws on the retaining ring.
And for all the fasteners in the hydrant valve, we do have torque specs for these fasteners. You can refer to the service manual to find out what these specific torque specs are. And for the most part, they're going to be inch-pounds. The only one that's going to be a little bit different is the maintenance valve. It'll be in foot-pounds. So you will probably need two different tools for this purpose.
Once you have all the screws securely fastened, we can move to the inside of the valve. First, we're going to install our check valve. Just sits down in the bottom. Our metal washer is going to sit right on top of the check valve. And we're going to install our O-ring and our Teflon seal. Now, these are both going to go inside the same groove down inside the hydrant valve. And we're going to install the O-ring first and then the Teflon seal.
And the O-ring is there for a purpose. Its intended purpose is to put pressure on that Teflon seal to the piston to help with that sealing surface.
And on this Teflon seal, you are going to see on this one, there are two different sides. One's straight, flat. The other one has a curved edge. We want to put the curved edge facing up, and then the O-ring will sit right behind it. Again, with this Teflon seal, we want to be careful that we're not putting any big creases or bends inside the Teflon because they will not come out. Gently work that Teflon seal in place. And again, we're going to smooth everything out with our hand. Make sure it's all fitted in there correctly. At this point, we're going to install our spring. We're going to set our piston on top of the spring. And we're going to have our retaining ring with our O-ring. I find it easier to have the O-ring on the retaining ring first instead of in the groove on the main valve body. And you can also use a little petroleum lubricant to hold this O-ring in place. Once I have everything fastened together, I push down on the retaining ring and get that piston lined up on that center shaft. And once I have everything seated, I can now rotate the retaining ring until the holes are aligned for my screws.
So as you push the piston back into place, you kind of want to feel for any type of resistance. If you do feel some resistance, you may want to stop, pull the piston back out, and re-inspect that Teflon seal to make sure we didn't pinch it or roll any seals as we're inserting.
Once we have 2 screws in place, we can go ahead and we don't have to put pressure on the retaining ring anymore. Additionally, with these screws, we do recommend putting anti-seize on the threads during installation. That will help the ease of getting these screws off into the future. And again, when fastening these screws, I like to use a star pattern. Once we have all the screws fastened on the retaining ring, we can flip the valve over, install our service valve, at this time, we're also going to install our roll pin. Again, you may need to get a new roll pin if you've damaged it during removal.
And as Jeff is doing, anytime you're using a hammer on these roll pins, you want to just give it light taps and work that roll pin in. We don't want to slam the hammer on the roll pin because you could actually damage the stem of the maintenance valve itself.
So once we have the roll pin reinstalled, we're going to reinstall the O-ring that goes between the lower half and the upper half. Now this O-ring, it may seem like it's a little too large to fit inside this groove, so you may need a little bit of petroleum lubricant to hold this O-ring in place. Just like that. All right, once we have the O-ring set in place, we're now ready to install the upper half. We want to make sure that we align the upper half so we go straight down on the lower, and we don't want to have to jostle around and have the potential of that O-ring falling out on us. So this is the orientation. The gap is going to align with the pilot valve. Once we have that in place, again, on our fasteners, we're going to have one short fastener and the rest are going to be long. That short fastener is going to go right above the service valve. And we're just going to get all these started. Now, once we have all the bolts securing our upper half to our lower half, that concludes the disassembly, inspection, and reassembly of the Eaton Carter ground fueling 60554 hydrant valve. Now we're going to go into a couple inspection items. First, we're going to start with what we mentioned earlier, inspecting our API ring. We have a go, no-go gauge, and we have 2 sides to this gauge, an A side and a B side. One side is going to check the total circumference of the API ring, and the other side is going to check the wear on the beveled edge underneath here. And this is simply running the gauge across the API ring at a couple spots on both the A side and B side. At any time when this go, no-go gauge slides across the API ring on either side of A or B, the API ring is worn out and needs to be replaced.
And this is a critical check. The importance of this check is, as a hydrant coupler is set onto the hydrant valve, it attaches to the API ring. If the API ring is worn, what could happen is during a refueling operation, that hydrant coupler could actually separate under flow. So this is a critical check. Definitely follow your local regulatory guidelines for the frequency of when to do this check.
The last item we're going to go over is a quick troubleshooting guide that you can determine on your hot pit condition whether you have an issue with your pilot valve or if you have an issue with the main valve itself. Bill, do you want to go over how to do this?
Absolutely, Jeff. So the first thing we want to do is kind of help you understand what is a hot pit. So a hot pit is essentially saying that we have hydrant pressure coming into the hydrant valve. And during normal operation, that hydrant pressure rests in that bottom half. What a hot pit is we've had some type of failure in the hydrant valve that's allowing that hydrant pressure to enter the upper half and build up pressure in this upper half. What you'll find is if you go to connect your hydrant coupler, you try to open up your operating handle, you'll feel a lot of force and you won't be able to open up that handle. That's probably a good indication that we have a lot of pressure built up in our upper half. So one quick test we can do to see, potentially is it our pilot valve that's failed or is it a main piston seal that has failed? What we're going to do is either use an approved pit integrity tester or your local guidelines for depressing this pressure equalization poppet. So what's going to happen is as we press this pressure equalization poppet with no dead man activated and no hydrant coupler attached, you're going to have a little bit of fuel that could escape from this poppet initially. Now that fuel should dissipate rather quickly. If I have this poppet depressed and fuel continues to escape, we have a potential hot pit scenario. So next thing we want to do is understand, is it the pilot or the main seal? So what we're going to do is we're going to turn in our maintenance valve. And as we turn this valve in, we just want to turn it until it's snug. As we mentioned before in the inspection, if we over tighten or use wrenches on this, we're actually damaging that seal and it can hamper with your test. So we're just going to tighten it till it's snug. We're going to come to the upper half, press our pressure equalization of poppet again. If fuel stops flowing out of the pressure equalization poppet, it's telling me my pilot was probably what was failed. If fuel continues to pour out while my maintenance valve is closed, it tells me we probably have a worn seal around the main piston in the bottom half. So that's the quick, really a static test for testing hot pits.
Thanks, Bill. That concludes our presentation video today on the 60554 hydrant valve.